Hi everyone, we are on to our second lesson on organic chemistry. Today is April 15th and we are going to learn how to name branched hydrocarbons. So first of all, the official name for naming compounds is called nomenclature. And these naming systems are developed by the International Union of Pure and Applied Chemistry, IUPAC. So I wanted you to be familiar with that because sometimes we could see that terminology used. All right, there are a number of rules required for naming branched hydrocarbons. The first rule is that we need to identify the parent chain. Always remember that the parent chain is the longest carbon chain. And if they want to get a little tricky with you, that carbon chain may not be straight. You will see some examples shortly. The second rule is that we're going to identify and name the branches coming off of that parent chain. These branches are known as alkyl groups. So I'm just going to give you 3 examples, but there are many others. It's the same type of prefixes, though, based on the number of carbons that you would see in table P. So a methyl group has 1 carbon, and it can be represented by CH3 this way, or C with all of the single bonds being shown between the H's. Ethyl groups would have 2 carbons with their hydrogens. Propyl would have 3 carbons with the hydrogens, and so forth. The third rule is if there is more than 1 branch coming off of a parent chain, we are going to name those branches in alphabetical order, excluding the prefix, if that applies. Again, we'll see some examples of that. So what I'll do is I'm going to leave the rules visible up there, and I've got a number of examples to go over with you. So our first example is, we'll look at, there's 2 ways to represent this, as I mentioned up here, all right, with the alkyl group. We can show, in this case, the alkyl group with the lines coming out, and the hydrogens could be shown on here, or we could show it clustered, carbon with 3 hydrogens that way. The bottom line is, let's look at the rules in order though. For number 1, we're going to find the longest chain. So if I look here, 4 carbons, 1, 2, 3, 4 carbons in that parent chain. So we know that this is a butane compound. Now, the location though of the alkyl group needs to be at the lowest location, the lowest number carbon. So we wouldn't make this 3, we'd make this 2. And it is a 1 carbon alkyl group, so it's methyl. So we're going to name this 2-methyl butane. This is the parent chain. This is the alkyl group or branch, and the number 2 is the location of the branch coming off that parent chain. Okay, let's look at another example. In our second example here, I've made it more challenging because I want you to be aware that sometimes we can find that the parent chain may not be straight. So what you need to do is look carefully. If I count across here, there's 4 carbons. If I count here, 1, 2, 3, 4, there's 4 there. But if I count here, 1, 2, 3, 4, 5, there are 5 carbons actually shown here. let me number that. That would be the longest carbon chain, and that will be the parent chain. And that's going to be a pentane. We then look here at the group, the branch coming off of that pentane. It's a 1-carbon branch. It is a methyl group. And you'll notice that methyl is located on the 3rd carbon. So we're going to name this 3-methyl pentane. Let's look at another example. All right, in my 3rd example, I've got a huge compound here. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 carbons here. That is the parent chain. So it's going to be an octane. And we've got a group. Actually, that alkyl group's pretty big. There are 3 carbons in the alkyl group. So when we look up in table P, we know that a 3-carbon group will be called propyl. Now we want to make sure we're numbering it correctly. 1, 2, 3, 4. That's the 4th carbon. If I number going in that direction. 1, 2, 3, 4, 5. That's the 5th carbon. So I'm going to number my parent chain as such. So I know the location of the propyl group is at the 4 position. So what is this called? 4-propyl, octane. 4-propyl octane. These are kind of fun. Once you start, playing around with them and you get a lot of practice, it becomes easier. Okay, so let's look at example number 4. When we look carefully, we see that there are actually 7 carbons in the longest chain. Let me number it. Okay, so we know we have a heptane in this example. So where is this alkyl group? It is on the 3rd carbon. So this is 3-methyl heptane. Okay. Let's see some other examples. All right, this one's going to be a lot of fun. All right, so here we go. First of all, we have 1, 2, 3, 4, 5. We have a parent compound that is hexane. We have 2 groups coming off of here. So this is where our 3rd rule will apply. If there's more than 1 branch coming off of that parent chain, we're going to name them in alphabetical order. Well, this is ethyl, and this is methyl. So ethyl is going to be named first. And ethyl is located on the 2nd carbon. And actually, so is the methyl. So we're going to do it this way. We're going to say 2-ethyl dash 2-methyl. And what is that? A hexane. Pretty cool. So it's alphabetical in alphabetical order. All right. What? You could actually get to the point where you would be actually writing the formulas from these names. And I thought I'd just go all out with this challenging example. So I'm going to kind of work backwards. Let me start with pentane. I know that that's my parent chain. Okay, it's the last name. There are 5 carbons in the pentane. Let me go back to the beginning. 2 is the location of ethyl. Well, 1, 2, if I decide, right, that's the number 2 carbon. I'm going to draw that ethyl group there. Then on the 3rd carbon, 1, 2, this must be the 3rd carbon. There's actually 2 methyl groups. 3,3-dimethyl pentane. Now, thankfully, we don't have to put in all the hydrogens, but you could see it with all the hydrogens in there. Okay, I'll just put the little dashes there. That implies that we have all those hydrogens there. That was fun. And that ends our mini lesson for today. And you'll get some more practice. Enjoy. Bye.